Today we're going to be looking at the interface class. So this is the interface class. Okay. Now an interface is not actually a class, so I've kind of introduced it incorrectly, unfortunately. So we are looking at an interface. An interface is simply a version of an abstract class. Now with an interface, we have several rules. Interfaces are not classes. They can give the headers for instance methods. Okay, so here's an instance method and we have the header of it. So we're in the interface pet. Okay, we've given the header for a pet method, which is to set the favorite food. We've not defined the implementation because the class that implements from it, which is the dog class, for example, will define the implementation. So if we look here in the dog class, you can see public void set favorite food. It receives one parameter, string f, and then in the curly braces we actually define how the dog implements the interface method. They can define static final variables, which we'll see shortly, using this format, public static final. They cannot define constructors, okay, because it's an interface, it's not a class. They can give the headers for static methods, as you've seen here. They cannot define instance variables that are not static and final. Okay, so if we have a look at this quick example, and we have two examples to review, this is the shorter of the two. You can see that we have the interface, okay, it has only one method, no variables or static final variables. This method is the set favorite food for the pet. We could have been more adventurous and added more methods, but we restricted it to this to keep it simple to begin with. Then we say class dog, and rather than extends, we say implements because we implement an interface. Okay, you can actually implement more than one interface just by separating with commas. Okay, whereas when we extend, which is inheritance, we can only extend one class. Here we essentially override this method here, or we implement it. Public void set favorite food, string f, and we print this. My favorite food is f. Okay, now what is f? Because we've not defined f. F will be the value that is passed as the parameter. Now in the test interface below, okay, which we may wish to call test class, probably be more appropriate. Test into class perhaps. Public static void main, we create a new object, okay, which is of type pet, which we can do, or we could have put dog, and then we simply say p.set favorite food, and we give the favorite food. So that's the first example. We're going to look at another example now. So if we just jump into the Netflix example. Now just to remind you, when a class implements an interface, the class agrees to implement all of the methods defined in the interface. So here we have Netflix is our interface, and we have two classes that are implementing Netflix. So you've got class Samsung that implements Netflix, and you've got class Apple that implements Netflix. Okay, so let's go line by line. So on our first line we have our interface, which is Netflix. Okay. Alright, on the next line we have a static constant, which essentially is our number of programs. Alright, now it's probably not the best type of variable to use here because maybe it will change with Netflix, but let's just say that it was fixed. And the fact is, with an interface you can only use static finals. So this is an example of a static final, which is essentially a constant. So this value will be the same for every class that implements Netflix. So we're going to say this is static final. Alright. Moving down, we have three methods on line 15, 16, and 17. Now each of these methods has to be implemented by any of the classes that implement Netflix. These are essentially abstract classes because, as you can see, abstract methods, because as you can see, Each of the methods has no implementation, and this is the standard format for an interface. So we have the accessor type, public. Sometimes you may not see this. Then we have void because it's an action, and it doesn't return. Then we have play, which is the name of our method. It doesn't receive any parameters. And then we don't have any curly braces because the implementation is done in the classes that implement. Then we have our semicolon. So these are essentially abstract methods. And in an interface, every instance method or even static method is an abstract method, but we don't need to include abstract in there. But the compiler will see an abstract method. Abstract meaning that it has no implementation because the implementation is done by the class that implements the interface. Moving down, we have our first class, which is Samsung, and Samsung implements Netflix. So we use the keyword implements to denote or to essentially create the relationship between the class and the interface. Okay, you can implement more than one interface if you wish. You would simply do that by adding a comma and then whatever other interface you wish to implement. The difference being with an inheritance and extension, we can only extend from one class, whereas here we can implement from many different interfaces. As you can imagine, Samsung, Apple would be using many different services on their devices. So that's kind of a good reason why. Moving down, we've got the play method that is being implemented. Now, if you can see the difference between line 15 and this line, or these lines here, is that rather than having a semicolon after the parameter, we have our curly brace, and inside the curly brace we have our statements. The statement for play, just making it simple, is system out print I play according to Samsung device protocols. Equally, with the rewind, I could do the same thing. The reason why I do not get an error message here is because I've added my curly braces and it's void. But I could simply add some statements in here, such as, and let me just delete that curly brace, that shouldn't be there. Okay, so inside I'm simply gonna say, let's just copy and paste this and then just edit it according to what rewind, the function of rewind is. So I rewind according to Samsung device protocols, essentially Samsung rules. Okay, and we've got our forward option here, and again I could add the method here if I wanted to. It doesn't matter here because it's void, so it's not going to give me any error. But if I tried to run this, obviously nothing would happen. So let's just add it in, why not? So in the statement, in between the curly braces, I'm just going to drop my print statement. I forward according to Samsung device protocols. Now if we look down again, we've got our class Apple implements Netflix, and it defines its own play method, rewind method, and forward method. I don't know why I had my curly braces there. Now if we look at our class Netflix test, this stores the main method, and this is essentially our driver class. Now if we look on the first line, line number 45, we instantiate, so we create a new object, instantiate a new object that is obviously implementing the Netflix. Now we say Samsung, so that's our Samsung here. Galaxy S20 equals new Samsung, so that's the name of our object, our reference variable. And we don't have any constructors in our Samsung, so we're using the default constructor, which is the 0 parameter one. Then on line 46 below, we also add our Apple, iPhone equals new Apple. Okay, now I could potentially say Netflix S10 equals new Samsung. Okay, that's also an option because Netflix is the type of item that I'm essentially instantiating here, and on the right hand side it will have the new objects. It's possibly not the best format to use, so I'll stick with my Samsung here. Okay, if I wish to do the S10. Then down below we have our Galaxy S20.play and our iPhone.play, and if I run the code here, you can see the output. I play according to Samsung device protocols. I play according to Apple device protocols. So this was the interface series, and essentially I was just explaining how an interface works. We had the rules that were here. When a class implements an interface, the class agrees to implement all of the methods defined in the interface, as we showed on the example. Interfaces are not classes, that's why it doesn't say class, it says interface. They can give the headers for instance methods, as you can see here, this is the header, but there is no implementation. They can define static final variables. As you saw here, there was a static final variable. We can't define standard variables. They cannot define constructors, so we cannot have any constructors in our interface because you can't instantiate an interface. They can give the headers for static methods, so we could also add a static method which would be public static void, which means we don't need an object to actually initialize this method. And they can not define instance variables that are not static and final. And that's essentially interfaces. Interfaces are somewhat useful in a sense when you don't wish to create the interface as an object itself. This could have been used in our human class, for example, because a human would obviously be a male or a female. So you would never really instantiate a human per se, but you would instantiate the inherited subclasses of the human class. So a human, if we were using our inheritance example as the humans, this would have been a good example. So that's all about interfaces. Any questions, please put them down below and I'm happy to get back to you. My challenge to you, can you create an interface based on an idea that you're interested in? Perhaps review the human inheritance and see if you can create now a interface using the human as the interface rather than a class, and define any methods that you need to define as abstract methods, and then call them in your subclasses, which could be male, female, could be father, son, etc. So have a go at that. That's my challenge to you. Thank you.